Good day. In this video, we will be presenting the experiment 4 entitled 8-bit interrupt on change. This experiment has two objectives. First, to understand how to interrupt on change works. 2, to apply LOC for controlling the LEDs. To execute this experiment, we will be using MPLAB X IDE program. To start the task, click File, New Project, then Microchip Embedded, then click Standalone Project. After that, click Next. Select the microchip which is the PIC 16F18875 microcontroller. Use XC8 as compiler. Lastly, save it to your preferred folder. In this project, we will be using three peripherals: System Module, Interruption Module, and Pin Module. This will be automatically included when you launch the MCC. Open the Pin Manager and then click on the RA4 output row. Select the blue lock symbol to change it to show a green lock symbol. Follow the same process on the RB4 input row, so it is lock and green. This adds the RA4 and RB4 I/O pins to the project. It should look like a picture below when created. After finishing the Pin Manager, click the Pin Module selection in the Project Resource section. The center section will show the Pin Module settings. It will show both RA4 and RB4 listed on the I/O chart. Number 1. The RA4 pin will be an output and control the LEDs. Click on the output box to make the pin an output. Number 2. Change the pin name to D2_LED. Number 3. The RB4 pin will be the input and will read the switch using the interrupt on change negative edge or IOCN, so it needs to be selected. Number 4. Change the pin's name to SW1. Under the System Module, proceed to Project Resource to open the center section. In this section, the oscillator settings and the configuration settings are selected. Under the Oscillator Select drop-down menu, select HFINTOSC. Under the HF Internal Clock drop-down menu, select 4 MHz. Select a clock divider value of 4. This will enable the internal 1 MHz internal oscillator as the system clock. On the Interruption module in the Project Resource tab, the interruption will be automatically set up because of the IOCN selected in the Pin module. The IOC interrupt is the only interrupt, so it is the first one to activate. After fixing the Pin module, Pin configuration, System module, and Interruption module, we will now proceed to the main C file. To access the main C file, first, click into the projects, then select a source file. After that, click the main C file. We will now input the code that we have come up to this experiment. After implementing the code, we will now build the project. The main C file requires a few lines to be uncommented for the interrupt to work properly. To enable the interrupt to work, global interrupt and peripheral interrupt needs to be uncommented. MCC has the control commands in the default main C file. They are just commented out with 2 forward slashes. After successfully building the project with the code we have come up, we will now transfer it to the MPLAB IDE. Connect the PK3 to your computer using a USB port, and after that, go to the advanced mode of the MPLAB IDE. To access that, go to Settings, click Advanced Mode, then type the password. To power on the PK3, go to Power, set the voltage to 3.125, then always enable the power target circuit from the PK3. After connecting the PK3 to the computer and the microchip, we can now program the PIC 16F18875. Now, this is the outcome of our experiment.
So this is experiment 4 on 8-bit interrupt on change. So when we supply power on our circuit, we can already see that the LED light is now on. We do also have switch in this type of circuit, in this 8-bit interrupt on change. But before we click the switch, the LED light is already turned on. So now let's click the switch. As we can observe, as we click the switch, the LED changed its phase. When we click the switch, it blinks, it turns off, and blinks again, and blinks again, and turn off. This shows that 8-bit interrupt on change has been used in this experiment. This is the last part of experiment 4. 8-bit interrupt on change. This allows us to control the LED from on to off, then off to on by clicking the switch. This allows us to change the phase of LED.